In this video, we're going to briefly talk about both 2 and 3-step algebraic equations and how to solve for x. The basic idea is that the 2 steps that you'll usually need to solve an equation are to first either add and subtract, and that's your first step usually, and then you're going to multiply and or divide. We'll look at some examples. This doesn't always happen exactly in that order, but that's pretty typical as to what you'll be doing. The 3-step, usually you distribute or divide first, depending on the scenario. Then you add or subtract, usually. And finally, multiply or divide. So let's talk about what these look like. Typically, you might start with a problem, let's say like this. Negative 2x minus 5 equals negative 15. So this is a 2-step problem, and here is our variable x. Our goal is to find out what the value of x is, and to do it in a way that's both efficient and accurate. So here we can add 5 to both sides first. We want to get x all by itself so we can read the answer, right? So that's our first step, adding or subtracting. I added because we have a negative 5 and I want to get rid of the 5 and get x all by itself. If I had subtracted 5 from both sides, that would still give me a negative 10 over here. It wouldn't get me any closer to finding the answer. So we have negative 2x, these equal 0, negative 5 plus 5 is 0, and this is equal to negative 10. Now we finish off by dividing. I would make sure to divide not just by 2, but by negative 2 here, so we can solve for x. Negative 2x divided by negative 2 is just x, right? 2 negatives divide to a positive, and x equals negative 10 over negative 2, which is positive 5. And that's our answer. So the 2 steps usually are to add first or subtract first, and then multiply or divide. Even in problems like this, let's say you have a fraction coefficient, 3/7 x plus 1 equals 13/7. Okay. So here in this scenario, we could subtract 1 from both sides first. This will work. And we have 3/7 x equals 13/7 minus 1, or 13/7 minus 7 over 7, right? 7 over 7 is still 1. So when you're subtracting these two fractions, you do have the same denominator. We're simplifying. Usually simplification or combining terms is not really counted as a step. So this is technically still part of one step. 13/7 minus 7/7 is 6/7. And here, right, to solve for x, we could multiply by 7 and then divide by 3 to get rid of this fraction, or multiply by the reciprocal, which is a nice, efficient way of doing this. 7/3 times 3/7 is just 1. And here, 7 times 6, 42, over 3 times 7, 21. That's just 2. And x is 2. So again, here in this 2-step problem, you can add or subtract first, and then multiply or divide, in both cases, by the coefficient. That's the number next to the x. So here we multiply by the reciprocal of 3/7, or that's really dividing by 3/7. Here we divide at both sides by negative 2. So you always divide by this coefficient. And again, the reason multiplying by the reciprocal is really dividing by the fraction is that that's the basic property of fractions. If you divide by 3/7 on both sides, just like we divided by this coefficient negative 2, you end up multiplying by its reciprocal, 7/3. A way around that, and there's always ways to manipulate this, these types of problems. You don't have to add or subtract first. Here you could have gotten rid of the 7ths right at the beginning by multiplying the whole equation by 7. 3/7 times 7 is 3, so it's 3x, plus 7 equals 13/7 times 7, which is just 13. So you can get rid of your fraction denominators by multiplying by certain numbers. Here, this would get you 3x plus 7. Then you could subtract 7 and divide by 3. But that would add more steps. However, it would avoid the fractions. Now, 3-step equations are very similar, except usually it involves the distributive property. So we'll solve this one in 2 different ways. So it might look something like this. You have a expression in parentheses times a number, in this case negative 4, and that will be equal to quantity. And I'll write this, actually I'll just copy and paste this. So we'll solve it in 2 different ways just so you can see what this looks like from 2 perspectives. So a more typical approach might be to first distribute. That's your first step. That adds the 3rd step. So let's try that. Negative 4 times x is negative 4x. Negative 4 times negative 2 is positive 8, and that equals negative 16. That was our first step. Now we subtract 8 from both sides, so now to that step where you subtract. Negative 4x equals negative 16 minus 8, or negative 24. And finally, we divide both sides by negative 4, or divide by that coefficient on x. So here, x equals positive 6. Right? So what would that look like here? What's another approach? Well, you could divide everything first. Usually, it's a good idea to divide everything if this number, the number you're distributing, is a factor of the number on the other side. And the reason that is because if this were a number like 17 or 15, dividing everything by 4 would give you an improper fraction, and that might make things more difficult than just distributing and then solving from there. But here, if we divide everything by negative 4, so usually you would divide by one of these factors here, watch what happens. These negative 4's cancel out, and you're left with just x minus 2. But you also need to divide negative 16 by negative 4, and that's just positive 4. And then we have a one-step equation to solve, so we add 2 to both sides, and x is still equal to positive 6. So notice here, in this case, by dividing by this number, negative 4, we turned a three-step problem into a two-step problem. It's not really about always finding the most efficient way to solve a problem. It's really about finding something that really works well for you. All right, hope this helped.